We'll start off with a review of what we did in class. We started with the rabbit world and showed these rabbits jumping up and down. And that was done in order to look at the do in order and do together blocks. And also a loop block. We started off with if you look here, you see loop infinity times, which means it'll just go through this code recursively over and over and over again. And so these will jump until I tell it to stop. Then within the loop block, we have a do together block, which covers the entire set of code. And then I've got a few do in orders and a do together. And then we wanted to figure out which rabbit was which based on the code here. And what we found out that the one named rabbit, which is the first one in this do in order block that goes up and down 1 meter, is this rabbit here. And we can see him going up and down 1 meter. Now we have another one going up and down 1 meter, but we can tell that he's different because of the timing, and we'll get to that in a little bit. Now here we have in a do in order block a rabbit moving up and down 2 meters, and that's rabbit 2, and that would be this one. Once again, we have another one going up and down 2 meters, but again, we can tell he's different because of the timing, and that helps us with our do in order versus do together blocks a little bit. We'll see that in a moment. And then we've got a third rabbit. It's in a do together block, and it has him moving up 1 meter, moving down 1 meter at the same time. That would be this rabbit. He's moving up and down simultaneously, and so there is no noticeable movement. Now in order to get to the next section of code, I've got to X this out and scroll down, and then we'll start playing it again. Here we've got rabbit 6 moving up 1 meter, rabbit 7 moving up 2 meters, then rabbit 6 moves down 1 meter, rabbit 7 moves down 2 meters. And that would be rabbit 6 is here, up 1 meter, down 1 meter, up 1 meter, down 1 meter. But after he moves up 1 meter, rabbit 7 moves up 2 meters. After he moves down 1 meter, rabbit 7 moves down 2 meters. And hopefully by looking over that, you'll have a better understanding of do in order and do together blocks. The next thing we looked at was the as seen by feature. And for that, I'm going to open a world called the as seen by world. And I've got this helicopter, and he's sitting on the ground, and in my code I tell him to roll left 0.15 revolutions and then move up 5 meters. And when I play the world, he rolls left and then he moves off at an angle, kind of looks like about a 45-degree angle from the camera angle that I'm looking at it. But I told him to move up, and yet he moved that way. Well, he moved up in relation to himself, not in relation to the ground. So what I can do to make him move, and that's fine with a helicopter because the rotors push on the air in that direction, and it will move in its own direction up and not in direction relative to the ground. But if I want it to move up in relation to the ground, what I can do is where it says helicopter move up 5 meters, where it says more, click as seen by, and then ground. And you can pick other things. It doesn't have to be as seen by ground, and see what they do. And then hit play, and now it moves up as seen by the ground and not as seen by the helicopter. Next thing we looked at was the point at feature. And I've got a line of code here that says canoe point at lighthouse. And when I play the world, you can see right now, if it shows up large enough in YouTube, you can see that the canoe appears to be pointed at the lighthouse, but let me play the world and we'll see what happens. We see the canoe spins around, the back end of it dips down into the water, and then it points up at the lighthouse. And the reason is because of the way Alice works. The lighthouse has a center that was defined by the graphic artist, and I would guess that center is right about here based on where the canoe's pointing. And the canoe has a center, and the center of the canoe lines up with the center of the lighthouse. And so it causes it to spin, so that the front points at it instead of the back, and also to tip. Now, if I don't want it to tip, what I can do is click this More and say only effect yaw is true. Yaw is is a term for moving left and right. And you'll often hear yaw mentioned when using a rudder in an airplane. But it works, it's the same idea with this canoe. So if only effect yaw is true, it now only spins around but does not change its tipping. Now, next thing we did is we looked at a world in quad view where I found that there can sometimes be some real difficulty in finding things when I go to quad view. I've got my buildings here and I can see them just fine, but when I decide I want to add objects and say go to quad view, very often they don't show up. Now, the folks in class told me they didn't have any trouble with this, but they might someday. And so I'm going to show you how to fix that. What you do is click this magnifying glass, then click and drag, and you can zoom out. And I have to zoom out pretty far here. Notice my buildings start showing up. And I can do that in each one of these, and click and move it, move up, click and zoom out, and there they are. And then I can click the hand and drag them towards the center if I want to zoom back in on them. When I zoom in, I'm going to click this, and I'm going to zoom in the other direction. They don't really stay in the center, so I have to go through that procedure a few times. Click the hand, recenter them. This one's pretty good now. Recenter. Then click the magnifying glass, zoom in some more, and then I've got my buildings where I can see them. Now, if you're working with really small things, for example, this gazebo, if that's all I had was gazebos, when I zoomed out, I wouldn't be able to find them. So what I would have to do is pick one of the small things, enlarge it really big, then zoom until I can find it, center it, get it where I want it, and then reduce it back to its normal size. Next thing we did is we went to examine the difference between move to and move toward. And I have a lifeboat here and an island, and I use these methods here to tell the lifeboat to move to the island. And so I pick move to down here, move to island, the entire island, and boom, it goes right into the island. Once again, here we're dealing with the centers of objects. When I tell it to move to something, the centers of the objects line up with each other. And so one becomes superimposed on the other one. And sometimes that might be what I want. Very often it is not what I want, so I have to pick something else. So I'm going to hit undo to get my boat back where it belongs. And if I want to move towards something, unfortunately, it doesn't work real well if I use these methods here. It'll work, but let me show you the problem. Lifeboat methods, move to. Whoops, I'm sorry, I want to do move toward. Lifeboat move toward. Now notice it only gives me these four options, from 1/4 meter to 2 meters. That isn't going to work in this case because the lifeboat is very, very far away from the island. It's just not even going to be noticeable. So I'm going to move it 2 meters towards the island, the entire island, and you won't even be able to see it move on YouTube. We could barely see it move in class. And I'll undo that. So in order to get it to really move toward the island, I had to write a line of code where I can change the amount more. And I said lifeboat move 50 meters toward the island. Play the code, and now it's moving up toward the island the way I want it to.